So in this video, we're going to be continuing our discussion on atomic theory, and in particular, we're going to be talking about subatomic particles. And our goal for this section is to identify the three major subatomic particles by symbol, charge, and approximate atomic mass expressed in atomic units, which we'll discuss as we go through the video. So despite the general acceptance of Dalton's theory, which we discussed in the last video, it was soon challenged by chemists. Their pictures shown here, such as Michael Faraday, William Crookes, Ernest Rutherford, and James Chadwick, who suggested that atoms are comprised of even smaller subatomic particles. And their work on separate occasions discovered the existence of electrons, protons, and neutrons. And we're going to be talking about these, but maybe you're familiar with seeing models of atoms similar to this one. And that's what we're going to be talking about in this video. So here's a summary of subatomic particles. This video is going to be fairly brief. And in the next video, we're going to be talking a little bit more about the nuclear model of an atom, worked by Rutherford. But for now, let's just look at the summary of subatomic particles. So we have electrons, protons, and neutrons. And so their symbols are shown here. So for electron, you have this little lowercase e with this little minus sign on the top. For protons, you can use one of two symbols, and you might see either one in your book, where you just have a lowercase p or a lowercase p, excuse me, with a little plus sign on it. And for a neutron, you might just have an n or an n with a 0 on the top. Okay, so those are the symbols for electrons, protons, and neutrons. The fundamental charge for these subatomic particles is given here. So electrons have a 1- fundamental charge, or a -1. Okay, protons are +1. And then neutrons are neutral. They have no fundamental charge, okay? So these are the fundamental charges for these subatomic particles. And we're going to be seeing this actually more as we go through the discussion of the book in different chapters, as well as this chapter, okay? So it's going to become more important as we go along. The masses are given here. They're incredibly tiny, okay? So an electron is 9 × 10 to the -28 grams. That is very tiny. Okay, protons and neutrons aren't much better. Okay, so these numbers are so small, so sometimes a unit known as an atomic unit is used to represent these small masses. So an atomic unit is just a very small unit of mass, equal to 1.66 × 10 to the -24th grams, used for atomic sized particles. So if you kind of do those conversions, you get approximately the following values. So the mass of an electron is 0.0005 atomic units, and the mass of a proton and a neutron are about 1 atomic unit. So that gives you a sense of scale, hopefully, of the differences between like a proton and an electron. And as far as their location, this is something we're going to talk about in a later video. But an electron is outside the nucleus, proton is inside the atom's nucleus, and then a neutron is also inside an atom's nucleus. So what do I mean by nucleus? Well, we're going to talk about that in the next video when we talk about the nuclear model for an atom.